Okay, so the next topic is introduction to turtle graphics. So this Python's turtle graphics system, this is basically like a GUI, like a graphical user interface for us to, it allows us to draw some shapes or patterns, like, some little drawings. So this always comes with a cursor, which is also known as a turtle, because for some reason it is shaped in type of a turtle. I don't know. So this is it comes with a small cursor, which is known as a turtle. So you can use Python statements to draw something shapes or different shapes around the screen. So when we are working with turtle graphics, we have to first import the library, that is import turtle. So this basically what a library is something that has predefined instructions, and we are not like defining everything from scratch, but we are importing something that is already existing. So this turtle is a module, and that is already existing, and we are trying to import that module into our program. So the syntax when you are trying to import any type of module into our program is import space the name of the module. So here import space turtle will be the first step when we are working with our Python programs. That is because as Python follows top to down approach, if we do not have this import turtle in the first statement, it will just cause an error that says turtle is not defined. So that is the reason whenever you're trying to import something, import a particular module, that has to go on top, followed by the next will be the followed functions, or will be the following rest of your program. So when you want the turtle to move to a certain distance, we will use the function forward. So this module turtle already has some functions which are predefined. That is the reason we are bringing the module itself. But if you are looking for a particular function to use from that particular module, that will be, the format will be name of the module dot the function that you are trying to call from this module. So as turtle already has a function that is forward, we are now trying to, in this statement, we are now trying to call that function forward from this module turtle. So we have turtle dot forward 100. So when this statement is executed, the turtle will move forward in 100 by 100 degrees. This is 100 pixels actually. Yeah, 100 pixels. And notice that the turtle is always facing towards the east. So whenever, like, if you're drawing something, let's say a square, so then we have to make sure that you are also aligned with the direction of that turtle. So it's east, then west, west is this way, east, north, west, south. That will give you a square. So initial heading is 0 degrees as well. So that is also important when you are trying to draw a circle which has degrees associated with it. And when you can use the turtle dot right angle, which will be the number in degrees, to turn the turtle to right with that angle. We can also use turtle dot left to turn the turtle left by that angle or that degrees. So let's take a look at this example. Turtle dot forward is moving the turtle to here, it's 100 pixels. And then you have turtle dot left 90. So now the turtle is facing up with 90 degrees. 90 degrees is exact parallel to whatever we had earlier, that is 100 straight line. So now the turtle is facing upwards. After the third statement, we have the turtle facing upwards. Now after the fourth statement is executed, that is turtle dot forward 100, the turtle from here is moving to straight up top to 100 degrees or 100 pixels. Same thing, another example, turtle dot forward 100, now right with 45 degrees. So the turtle position is in this way, it's pointing its head towards this way with 45 degrees angle. And then now it's moving forward with 100 pixels. So you can always specify, instead of using right and left, you can always specify the angle or the position of the heading of the turtle, which is otherwise called as set heading. So you can adjust the heading or the direction of the heading of the turtle by using the set heading statement. So here first we have imported turtle. Now imported turtle dot forward is 50. So now the turtle is here after the second statement is executed. Turtle dot set heading 90 will make its position 90 degrees. So this is according to the Cartesian coordinate system. I'm not sure how many of you are familiar with Cartesian coordinate system. This is like this. This is 0, 0. This is x-axis. Oops. This is y-axis. And this is 90, 180, 270, and 360. So that is the Cartesian coordinate system. So based upon this, so when the turtle is set heading 90, it is facing upwards. And now turtle dot forward 100, it is moving forward to 100. Now set heading 180 is facing this way, towards the left. So it is now here pointing towards left. So it is again turtle dot forward, it is moving forward with 50 pixels. Turtle dot set heading 270 is towards the down or south. So now it has its face pointing downwards. Turtle dot forward will move the turtle 100 pixels towards the bottom. So that gives you a rectangle. I hope this is clear. Okay. Oops. Okay. When the turtle pen is down, so when the turtle's pen is down, that will give you some output on the paper. So let's take it as pen and paper. If you have your pen tip down, only then you can see some output on the paper, right? If the pen tip is above, like up, then you cannot see anything that is being printed on that paper. Same logic here, when the turtle's pen is down, it will draw a line. By default, the turtle pen is down itself. If you do not want the turtle pen to draw anything, then you can just turn the pen to up. That is by using the statement turtle dot pen up. And if you want to put that pen down again, you can just do turtle dot pen down. This is important when you want to draw dotted lines or dotted dashes or anything like that. So first imported turtle, next moving forward to 50 pixels, turtle is here. Now it's pen up. So pen, now the tip is no longer on the paper, but you're still moving 25 points. So there is no line, but the turtle is now here. At this point, if you want to print anything, you again do pen down. So that will bring the tip back to the paper. And now you're moving forward to 50 and so on and so forth. When you want to draw a circle, there is a function that is circle inside the turtle module itself, which you can directly import. So turtle dot circle 100 will give you a circle with radius 100. So the argument inside the circle function is the radius. And if you want to demonstrate some dots, again, when you are on your Cartesian coordinate system and you want to plot some data, then in that case, you can use the dot function. So turtle dot will print a dot, like we'll leave a dot on the screen. So first starting with dot, next moving forward with 50, and again you have a dot moving forward with 50, again a dot moving forward with 50. And you can also change the pen size and pen color of turtle. So turtle dot pen size is now set to 5. Pen color is set to red. Then you have turtle dot color as 100. Same, you can change the background color, which is short for BG color, which is short for background color. You can select the colors as well. And you can set the turtle width and height of the window in pixels. So that is something like turtle dot setup 640, 480. So resetting the turtle's window is, you can directly type turtle dot reset statement, which will erase all the drawings, resets all the colors to black, bring its original position to the center of the screen, no matter where that is, but it will do not remove any background color. Will clear all the drawings, but does not change the position, does not change the drawing color, does not change the graphics window's background color. Dot clear screen will remove everything. It will bring back the turtle to its original position, make it black, clear all the drawings, and also change the background color to default, which is white. So as I've mentioned, Cartesian coordinate systems is something that is very important when you're working with turtles. So again, when you want to go, you can use a specific statement that is turtle.go to when you want to move the turtle to a specified location based on Cartesian coordinate system. So here it is 0, 0. So maybe this one could be like 5 and then 10. So x comma y, right? That is 5 comma 10. So if you want the turtle to go to this point, it is turtle dot go to open parenthesis 5 comma 10. In this case, we are going to 0, 100. That is x is 0, y is 100. So you're starting from here, going up. Again, we have minus 100, which is left side on the x coordinate system because all the negatives. And then we have 0, that is for y. That is, there is no coordinate on y. So when you are here, minus 100, 0, then it is directly dropping to here, minus 100 and 0. Next is 0, 0. So now back to here. So this will, in this way, it is easier to draw statements. So instead of having 7 to 8 statements, you can just complete the right angle triangle in 3 steps. So that is a major advantages of using GoTo. And also when you are plotting constellations, this is also easier. It will just make the job easier when you are plotting constellations as well. And turtle.pos will display the turtle's current x coordinate systems, xy coordinates. Turtle.xcor will determine the turtle's x coordinate, and turtle.ycor will determine the y coordinates of this turtle on the specified, like on the template or on the window. And for the animation speed, you can always check with the animation speed, that is turtle.speed. Speed is an argument in the range of 0 and 10, 0 being the fastest. Like when you hit 0, you cannot see the turtle moving in all the directions, but you can instantly see the output directly. And 1 through 10, 1 being the smallest, like the lowest speed, and 10 being the highest speed. And if you do not want to see the turtles after your graphic is done, then you can just use turtle.hide turtle instruction to hide the turtle. If you want to show the turtle again, you can use turtle.show turtle. If you want to write text on a particular output, like for example, if you are plotting the constellations and if you want to name the constellations with respect to their coordinates, in that case, you can just use turtle.write and then text beside that, and that will be printed on your XY coordinate system. So this is import turtle.write, hello world. So you are writing hello world, and that is at the 0, 0 location. So that is the reason why you see hello world on your turtle graphic window at 0, 0 coordinate system. So if you want to fill a shape within a color, then you can just directly do turtle.beginFill. That will start the command, and that turtle.endFill is the ending command. And after this, the shape is drawn. So when the turtle.endFill command executes, the shape will be filled with the current fill color. So we can see an example. So first step is turtle.hide turtle, because I do not want to see the turtle shape. And then fill color is set with red. Next, I'm starting the begin fill, and then all the images or all the shapes which I want to be filled must be inside the begin fill and end fill. So in this case, it's just a circle. So I'm just calling the function circle. So turtle.circle with 100 as radius, and then end fill. So after this program is executed, you will see a circle with 100 radius, which is filled with color red. Okay, so for us, as we are using idle, there is no need to do turtle.done statement. But in general, when you are done, when you're working on any other interpreters, when you're done with the graphic, it is good practice to just type turtle.done statement, which will basically let the program or the interpreter know that you are done with turtle statements. Okay, so now let's take a look at this. So first is import.turtle. When you run this opens another window. Okay, so when you are importing turtle and you are running the statement, if you do not see any errors, that means that import was successful and there were no problems. So if you want to see the turtle, we can just do show turtle. And here is my window with turtle. And for this turtle.forward, keeps coming to my second screen. Forward. Now, if you want to create a right angle triangle, not right angle, just using the right angle, that is turtle.right. this turtle dot right. Now, when you want to execute turtle dot left, it has to be as a command. Oh, this is basically the continuation of the previous part. So I'll have to make sure that you are commenting whatever that you are not using. So let's comment this one as well. Now left angle. This is the output of left angle. That is my primary screen. So maybe because of that, everything is being displayed there. Okay, so instead, wait, I'll start a new share with my screen 1 so that we can bring this here and you can see the output here. Okay, so the next is setting the turtle to a specified heading. So by using the set heading function, I'm again commenting the previous part. Control S. Oops. Okay. Control S and then F5. That is my turtle graphics with set heading. And then if you are specifying the same, you can always close the window because anyways, it will just bring another window up. So I'm commenting this part and uncommenting this to demonstrate pen up. So this basically all these .py files are for you whenever you are going through this lecture. If you want to practice more, I would suggest start with this .py files because they help in understanding a lot and it can make your labs and your programming assignments way easier. So that will give you a circle with red color pen. Pen color is set to red. Now, when you are trying to draw background color to gray, let's comment this. Now I change the background color and the pen color is still red. So if I want to change the speed, Control S, Windows F5. So it is the speed of 8. Now, if I just specify the speed to 0, it should be instant. And the statement, whatever you want to see the speed of the circle, that statement has to be below the speed 0 because you are working with top-down approach. So now that is your instant graphic. Did not demonstrate anything. So if you want to look at the difference, see this is the first statement. And then, okay, the second statement is still the same. That's the reason you don't see anything. Okay. Now displaying text. If I write hello world, there you go, hello world. If we want to specify the size of the window, that is sometimes required. So sure, why not? Yes. The hello world is from the previous line of code, but anyway. So this is a good example because in the lab, we are going to work with constellations, or maybe in the programming assignment, there is a constellations problem that you'll be working with. So in that, you are asked to go to a certain location and then write the name of that location, go to a different location, write the name of that location. So there you'll be using all the functions that all the function calls that we have used, that we have discussed in Turtle graphics in the same lecture. Okay. So we have adjusted the turtle width to window width to that is 300 and 300, and in the top left, that is in this location -120 to 120, you are writing top left. And 70 and minus 120, you're writing it as bottom right. And now filling shapes. Control S. Drawing a circle and then filling its shape with black. Sorry, red. Once you're done, you can just execute the statement as well. But as I've mentioned before, it is not required for idle because our interpreter does it automatically for us. Yeah, okay. With that, we are done with chapter 2. I'll be posting the lab and the quiz for chapter 1 in this week. So watch out. Okay, see you next week. Bye, guys. If you have any questions, reach out to me or to the TA. The TA has mentioned his office hours. I'll update that office hours in the syllabus as well. So please reach out if you have any sort of questions. We can work through those as well.